Hi. So for chapter 4 we are going to learn about the random variables and discrete probability distribution. So let us have a look what subtopics we have in chapter 4. So in chapter 4 we have 3 subtopics, which is the first subtopic we are going to learn about random variables and probability distribution, which is in first subtopic we are mainly going to focus on probability distribution. And then for the second subtopic, we are going to learn about binomial distribution, which is binomial distribution. I will be teaching you binomial distribution in the second part of the video. And the third subtopic is about Poisson distribution. And also the same thing for Poisson distribution, I will be teaching you Poisson distribution in the third video. So for this video, we are going to focus on probability distribution. So probability distribution, for the probability distribution, we have 6 properties of probability distribution, which is the first properties of probability distribution says that sum of all probability equals to 1. So this is the first properties of probability distribution. Sum of all probability equals to 1, which is the formula given to you is total of probability equals to 1. The second properties of probability distribution is if you want to calculate the mean of probability distribution, or we also call it as expected value. So the formula given to you is E of x, which is E represent expected, x represent our variable, and the formula given is the sum of x multiplied with the probability. The third properties is the variance. So the variance, the formula of the variance given, so we represent variance with VAR of x, which is x again is our variable. So the formula given is E of x squared minus EX, which is with and then for the fourth property is a standard deviation. So again, standard deviation, if you already have variance, so to come up with standard deviation, we need to square root variance, which is variance is the third properties that we calculated. The third properties of the probability distribution. And the fifth properties of the probability distribution is function of x. So whenever you are being given a function of x, which is we usually represent function of x with y. So y equals to ax plus b. So if you want to calculate the mean and the variance for the y, so this is a formula given, which is the mean of y is a expected of x or mean of x plus b. And then for the variance of y is a square variance of x. So where can we get the value of a and b? A and b will come from the function of x, and the value of ex and also variance x comes from the value of the second and also the third properties of probability distribution. And the last one is the probability, the properties of probability, which is this one you want to calculate the probability. Okay, so let us have a look at the example how we are going to apply all these properties of probability distribution on a probability distribution. Okay, so first of all, what is probability distribution? So probability distribution is a table, which is, this is a probability distribution, which is in this table, you are having two values, which is the first value is the value of x. So the first value is the value of x, which is x is the observation of your variable, which is in this case, our variable is number of cars sold per day. So we know that number of cars sold per day is in terms of the discrete variable or discrete data. Okay, because we are counting our number of car. 1 car, 2 cars, 3 cars sold per day. We won't have 2.3 cars. We won't have 3.4 cars sold per day. So again, our variable is about number of cars sold per day. So our variable is about the discrete variable. And the X here represent what is the value in our observation, or what is the value for our data. Alright, okay, and then the second value in the probability distribution is Px equals to X, which is, this one is the probability for each of the value of the data. So let us have a look at the value of the data that we have. So if we can see that small x value that we have 0, we have 1, we have 2, 3, and 4. So what's all this value means? So let's say we go with 0. 0 means that there is no car sold per day in a day. So, and then 1 here is 1 car sold in a day. 2 means that 2 cars sold in a day. So the same thing goes with 3 and 4. So that is the number of cars sold in a day. So that is our data for the number of cars sold per day. Alright. And then the Px equals to X here is the probability of the car is not sold per day. So let's say for 0, 0.1 means that in all the day, if you cannot sold the car, it means that the probability of you cannot sell any of the car is 0.1. And for number 1, 0.35. So 0.35 means that the probability or the chances of you can sell in a day only 1 car is 0.35. For 2, which is 0.15, so this is also the same thing. The probability of you can sell only 2 cars in a day is 0.15. So that's the same thing goes for 0.15 and also 0.25. So that is the probability distribution, which is you are having a table, and in the table you have the value of the data, which is the X, and also the probability for the value of the data. Alright, okay, so now you have the probability distribution. So we have the table here. So now we want to apply the 6 properties of the probability distribution. So we go with the first properties, which is the first property says that sum of all probability equals to 1. So we know that in the table, we already been given probability, which is the value of P. So if we are having probability distribution, so if we add all the probability value, it should be equals to 1. So we have the formula here, which is the total or the sum of probability is equals to 1. So we add all the value of probability. So we have 0.1 plus 0.35 plus 0.15 plus 0.15 plus 0.25. So we add all the value, we will come up with 1. So means that our first property is fulfilled. Alright, so that is for the first property. And then the second property of the probability distribution is to calculate the mean, which is mean, we also call it as expected value. Okay, so we represent mean with EX. So again, the formula given to us is sum of X multiplied with the probability. Okay, so again, for the probability, this one, if you have Px equals to X, or if you are being given P of X, it's also the same thing. Okay, so meaning that here you need to multiply your X with the probability. You multiply the X with probability. You multiply X with probability. And then for the sum, you add them all together. So meaning that here for the first X and probability. So we have here 0. And we need to multiply with the probability 0.1. So we have here 0 multiplied with 0.1. Since that we need to have the sum of them, so we need to plus. So we plus here. Alright, and then for the second x, so we have 1 with 0.35. So the same thing, we need to multiply 1 with 0.35. So we multiply 1 with 0.35. So again, for some, we need to plus. So you need to do all the same thing for each of the x. So we multiply 2 with 0.515. 3 multiply with 0.15. And 4 multiply with 0.25. So we add them all together. Alright. Okay, so after we multiply, then we plus, then we calculate all the values. So we will come up with the value of the mean, which is 2.5. Note that is whenever we come up with the value of mean with the decimal places, it's okay. Don't round up or don't round down the value to the whole number. Alright, okay, so meaning that in this case, in order for all of the car to be sold for the same amount of car or the same number of car in a day, so it should be sold for 2.1 cars. So again, if you have the decimal for the mean value, it's okay. Just leave it as a decimal places. Alright, so that is the second properties of the probability distribution. And then for the third properties of the probability distribution is given for the variance, to calculate the variance. So again, the formula given to us is variance is the expected of x squared minus with the expected of x, we square it. If you still remember, expected of x here is the value of our mean. So we have no issue for the expected of x. To substitute the value, we just can substitute the value of mean later for this one. But for the expected of x squared here, so how to come up with the expected of x squared? So the calculation is the same with the expected of x. It's just that you need to square the value of your x, which is that if we look at the table again for the probability distribution, 0 with 0.1. Our x is 0. So it means that we need to square the value of x first. Then we multiply with the probability. So then we have here 0 square multiply with the probability. Then again for the total of it, you need to plus. Then again for the value of x, 1 square multiply 0.35. 2 square multiply 0.15. 3 square multiply 0.15. And 4 square multiply 0.25. So we are squaring the value of the x. And that is for this part here. This is for the total of x squared or the expected of x squared. And then we need to minus. Then with the expected of x. And then you square it. So expected of x, we just calculate for the second properties, which is 2.1. So we substitute with 2.1 and then we square it. Then we can calculate for the value. So we will come up with 1.89. So that is our variance value. And then for the fourth property of the probability distribution is we want to calculate for the standard deviation. So whenever we have variance, automatically we can have standard deviation, which is again to come up with standard deviation when you are having variance, you need to square root the variance. So this one, you just square root the variance, which is the variance value, is the one that we calculated in the third properties just now, which is 1.89. So we just substitute, so we will come up with 1.37. So that is the standard deviation for this probability distribution. Right? Okay, so let us move on to the fifth property, which is function of x. So let's say you are being given a function of x, which is y equals to 2x plus 5. So you know that y is the function of x. So you know that in the general term of function of x, you are being given y equals to ax plus b. So this is the general form of function of x. So again, if you are being given another function of x, which is y equals to 2x plus 5, so you are being given in terms of a value, y equals to 2x plus 5. So automatically you can find what is your a value and what is your b value. So here you can see that your a is 2 and your b is 5. So once you have the A and B value, then you can find the expected of Y or expected of the function of X, and you also can find the variance of Y or the variance of function of X. So for the first one, mean or the expected of Y. So this one, expected of Y, we are being given the formula which is A multiplied with the expected of X plus B, which is our A value is 2, our B value is 5, coming out from the function given to us. Okay, so you just substitute the value. So A you know is 2. Expected of X, you just calculate expected of X just now in the second properties, which is 2.1. So you just substitute the value and then plus with B. So again, B is 5, so you just substitute. And then you can calculate for the value of expected of Y, which is 9.2. And then for the variance, again, the formula of the variance of Y is A square variance of X. So again, you know the A value is 2, so you just substitute the A value 2. And then you have square, so you have square, and then the variance of X. So again, variance of X, we already calculate just now the variance of X, which is 1.89 in the third properties. So again, you substitute the value, and then you can calculate the value. So you will come up with the variance of Y or the variance of function of X, which is 7.56. Alright. So all of the formula have been given in the formula booklet. So you need to know how to apply the formula. Alright. Okay, so that is for the fifth properties of probability distribution. So we move on to the last properties, which is how to calculate the probability for probability distribution. So again, whenever we are calculating the value of probability for probability distribution, or discrete variable, so you need to look out for the symbol or the phrases for the probability that we want. Alright, so I have the phrases or the meaning for the symbol that we want to calculate for the value. Okay, let's say we are having this question. Let's say we are having these three examples or the three questions for the calculating probability. So let's say the first question asks you, what is the probability of exactly 3 cars sold per day? So again, you know that 3 cars sold per day is discrete variable, and the question asking for what is probability. So when the question asking for what is probability and you are having probability distribution, so we are going to look at these phrases to calculate for the probability. So what probability that we want to calculate? So probability, we are going to represent probability with capital P. So P, capital P represents the probability. Okay, so probability that we want to calculate, probability of what? So it says that cars sold per day. So cars sold per day is our variable, which is in terms of X. Okay, and then it says that exactly 3 cars sold per day. So again, for this exactly 3, so we need to look at the phrases that we have in the table just now. So exactly. Exactly. So here is exactly. So exactly means that we are having X equals to 3. So meaning that in our probability just now, what we want to have is probability of X equals to 3. So now again, you know that X is our variable, which is 3 is the number of variable or the number of the data. So again, for the probability, we can just straight away refer to our probability distribution, which is referred to the table. So X equals to 3 means that our X value is 3. So X value is 3. We can see that here is X value of 3. So means that the probability of exactly 3 cars sold per day is 0.15. So we can write our answer here, which is 0.15. Alright, okay. Let us go with the second one, which is what is the probability of less than 3 cars sold per day? So again, we want to calculate the probability. So what we have here is P. Okay, so probability of what? probability of less than 3 cars sold per day. So less than, again, what is the symbol for less than? So again, we refer to our table. So less than, so we can see that we have here less than. So less than means that you have x less than 3. So you can write down your probability. So x less than 3. So again, we can see that this one, less than is not equal symbol. So we need to change this less than into the equal symbol. So less than means that 3 is not included. Because it says that less than 3, it means that 3 is not included. So what is included is 0, 1, and 2. That is less than 3. So means that in terms of equal symbol, what we have here is probability of x equals to 0 plus with probability of x equals to 1 and plus with the probability of x equals to 2. So again, 3 is not included because it's less than 3. So again, for all of this probability, we can find in the table. So again, for 0, 1, and 2, so we have 0 is 0.1, 1 is 0.35, and 2 is 0.15. So we can plus all this value into our probability. So we have here probability of 0 is 0.1. Probability of 1 is 0.35. And probability of 2 is 0.15. Let me check whether it's correct or not. Yep, it's correct. So now after we substitute with the value, so then we can calculate the probability. So 0.1 plus 0.35 is 0.45. 0.45 plus 0.15, so you will have here 0.6. So that is the probability less than 3 cars sold per day. So we go with the last one. So it says that probability of no less than 3 cars. So what is the symbol again for no less? So no less, we refer to the table. No less than, so we have here no less than. So no less than, so you know that your symbol is x greater than or equals to 3. So means that here for the probability, again calculate probability. So it means that you have p x greater than or equals to 3. So again, you are having greater than or equal. It's not in the equal symbol. So you need to change this one in terms of the equal symbol. So you know that when you are having greater than or equals to 3, 3 is included because you are having the greater than or equal symbol there. So again, 3 is included and greater means that to 3 to the higher value of the x. So again, what we have is in our table, we just have up to value of 4 of x. So what we need to plus is x equals to 3 plus x equals to 4. So for this one, we are having here probability of x equals to 3 plus with the probability of x equals to 4. So that is our probability value for x greater than or equals to 3 or no less than 3. So again, for x equals to 3 and x equals to 4, probability, refer to our probability distribution. So for 3 and 4, probability value, what we have is 0.15 and 0.25. So then we can substitute. So we have here 0.15 plus with 0.25. So we can have here the value we plus is 0.4. So that is the probability of having no less than 3 cars sold per day. So that is basically for the first subtopic, which is probability distribution for the fourth chapter, chapter 4. So I will see you in the second video for the second subtopic.